Welcome to Study Loop.
Hello students, in this question we have to calculate the total distance the electron travels over a period of time. So let's divide this into three segments so that we can calculate three distances, and finally we can add all the three distances and we get the total distance. So the first segment 1. Here the an electron accelerates from rest, so that means u is equal to 0, and this acceleration is about a is equal to 5.33 into 10 power 12 meter per second squared, and this acceleration lasts for about 0.15 microsecond. So this is our first segment. In this segment, first I am going to find the displacement. So displacement during this segment, that is S1, let it be, and this is equal to ut plus half at squared. This is the kinematic equation I am using here. Since u is 0, the first segment will be 0, and this is half into 5.33 multiplied by 10 power 12 into 0.15 into 10 power minus 6 to the whole square. As a result, the first displacement is 0.06 meter, or in terms of centimeter it is 6 centimeter. Now I am finding the final velocity of this segment. So we know that acceleration, that is a is equal to rate of change of velocity, which is nothing but final velocity minus initial velocity divided by t, and here I am going to find the final velocity, that is v is equal to u plus at. This is 0 plus 5.33 multiplied by 10 power 12. This multiplied by 0.15 into 10 power minus 6, so that I get the final velocity v as 8 into 10 power 5 meter per second. So the final velocity of the first segment will be the initial velocity for the following segments. Now let's move over to the second segment. For segment 2. So for this segment, the electron then drifts with a constant velocity for a time of 0.2 microseconds. That is 10 power minus 6 seconds. So constant velocity means in this case the acceleration will be 0, and here the constant velocity is 8 into 10 power 5 meter per second. Now here I am finding the displacement S2. So S2 is equal to ut plus half at square. In this case, only the first part remains, that is 8 into 10 power 5 multiplied by the time is 0.2 into 10 power minus 6, and as the acceleration in this segment is 0, this term will reduce to 0, and we get the displacement during this phase is 0.16 meter, or in terms of centimeter it is 16 centimeter. And now we are moving to the final segment, that is segment 3. Segment 3. Here the electron finally comes to rest with an acceleration. So comes to rest means the final velocity here will be 0, and the initial velocity will be the same, 8 into 10 power 5 meter per second. And it was also given the acceleration, here it is deceleration, this is minus 2.267 into 10 power 13 meter per second square. Now I am finding the time first, so that is time taken for this segment. This is calculated from the acceleration. So acceleration is equal to v minus u divided by t. From this I can get t. So minus 2.267 multiplied by 10 power 13, this is equal to 0, minus u here is 8 into 10 power 5 divided by t. So therefore I get the time period for this segment is 3.52 into 10 power minus 8 seconds. So using this time period I can find the displacement of this segment S3. So S3 is equal to ut plus half at square. Here u is 8 into 10 power 5 and the time period here is 3.52 into 10 power minus 8 plus half, this is 0.5, and acceleration here is nothing but the deceleration, that is minus 2.267 multiplied by 10 power 13, and t squared is 3.52 squared into 10 power minus 16. That is, I am squaring this. So if we solve, we get the displacement for this segment is equal to 1.40 centimeter, and therefore so the total distance travelled by the electron S is equal to S1 plus S2 plus S3. So this gives 6 plus 16 plus 1.40 centimeter. As a result, the total displacement of electron is 23.4 centimeter. This is our required answer. Hope you find this video is useful. Thank you.